can use machine learning based models. Let's assume, practical example, let's assume we have power amplifier here and we have input signal X and the power amplifier gives us output signal Y. Now this power amplifier has a mathematical model that links the output with the input. Now this mathematical model, if you go and search in the literature or read about it in books, you will find it extremely complex, nonlinear, complex, memory, multipolynomial. It's headache to deal with it. Usually, like an equation like half page of this and that, and you don't know how to implement it, summation, multiplication. So the model is difficult, and sometimes it's not like accurate. So what do? You go to the lab, to the experiment, and you find a practical power amplifier, like hardware device. You get the input, this is your power amplifier in the lab, and you just send a random signal through the power amplifier. The power amplifier will give you a practical output. Why? So when you have input, you have output, you have here that, you need to link the output with the input, but it's very difficult to find a mathematical model that can build the relationship between them. So one way to understand the relationship between them is to use machine learning, neural network, supervised learning. What you do, you build your neural network. Let's say the input data here was x1, x2, x3, and so on, and the output here is something like y1, y2, y3, y4. All what you need to do is to find the weights of a matrix obtained from the neural network-based training process that can map the input to the output. Once you find this model, these weights that you will find from the machine learning training process are going to represent the model of the power amplifier. You are going to remove this now after you train and replace it with the machine learning model that you found during your training. Now, what's the beautiful thing about this? Once you know the model here, and we know the effect of power amplifier, what your power amplifier causes to your signal, it causes distortion. What you can do is you can inverse this model so that you get rid of the non-linearity problem in the power amplifier. So at the end of the day, any model, any system, any channel, any equalizer, you can replace it with something that's machine learning based or machine learning dependent structure. Why this is helpful and useful? Because it allows you to build a relationship between input and output without the need to know the mathematical equation of the model. And this can help you build equalizers to remove the effect of each and every device. Help you detect the data correctly without knowing the mathematical equation of that device or that channel. That's the big advantage of using machine learning based models. And thankfully, we have super powerful computing power using NVIDIA, GPU, CPU. The training process is going to be very quick, and all what you need to do, the most difficult task or the most important task is to get the data, the reliable data, the data set, we call it in image processing perspective. Input, output. Once you get the input and output, all what you need to do, I will share with you a Python script. All what you need to do is to upload the input, upload the output, build the neural network structure, and then train it to get the weights. And then start using these weights, multiply them with the input to get the real output.